Over the last few months, while evaluating these large language models, we have seen that these LLMs really don't perform well with mathematics. This project, VMath, which is inspired by human like mathematical reasoning, asks a lot of poignant questions from LLMs around mathematics. This VMath is the first benchmark specifically designed to explore the problem solving principles beyond the end to end performance of LLMs. They have very meticulously collected and categorized 6.5 thousand visual math problems spanning 67 hierarchical knowledge concepts and 5 layers of knowledge granularity, as you can see on your screen. What they have done is that they have followed the process of decomposition. If you really think about it, then human cognitive and reasoning patterns have profoundly shaped the progress of deep learning over the last few years. Initially, the design of neural networks is inspired by the brain's neuron mechanisms. It uses convolutional kernels and hierarchical network to mimic human cognitive process of knowledge acquisition. Recently, transformers have employed attention mechanism to handle multiple information flows and quickly focus on critical content, so achieves more efficient and in-depth sequential learning. Owing the scalability of the transformer architecture and pre-training techniques, LLMs and other multimodal models, which we can call LMMs, have showcased strong reasoning abilities and parallel human performance across a wide range of tasks and provide a glimpse into early outlines of AGI. Mathematical reasoning is a critical capability of models. Existing models employ chain of thought, program of thought, tool integrated techniques, and data augmentation strategies to guide LLMs toward emulating human like reasoning patterns. In a more challenging scenario, visual mathematical reasoning requires the model to accurately decode the visual information in image and performs reasoning based on textual problem. With the rapid advancement of LMMs, researchers progressively utilize the LMMs for solving visual mathematical problems. These studies provide valuable insights into the ongoing improvements in multimodal logical thinking capabilities. To systematically evaluate visual mathematical reasoning capabilities, all of the previous efforts have focused on challenging geometrical problems. Recently, several benchmarks expand the scope to include a wider range of disciplines, but these benchmarks rely only on end to end results for assessment, which really fails to identify inherent issues within the LMM's reasoning process. Also, such as MathWorks attempt to directly evaluate reasoning paths based on reference answers, but limitations remain due to the knowledge intensive nature of math reasoning. While noticing that humans solve complex math problems through gradually mastering and generalizing the knowledge concepts, we have claimed a fair evaluation of a model's reasoning process. That is why there are two main questions which they are asking in this paper. First, does the correct answer truly reflect LMM's ability to reason through such problem accurately? Secondly, does an incorrect answer suggest a lack of model's knowledge in LMM's reasoning process? That is where this VMath comes into play. Now, if you look this diagram again and statistics of math, they are first decomposing composite problems into sub-problems according to the required knowledge concept and introduce a new four-dimensional metric which is named as insufficient knowledge or IK. And then there is another one which is called as inadequate generalization or IG, complete mastery CM, and rote memorization RM to hierarchically assess inherent issues in LMM's reasoning process. So as you can see here, this is a pipeline of knowledge-based data decomposition where they are showing the example of a three-step problem in VMath. So in this three-step problem, if you see the collection is that there are few knowledge concepts including cardinal directions and circumference of circle. Condition is that Mary walks from the northernmost point of the circular flower bed along the edge to the easternmost point, and there is also a diagram for LMM. And question is what is the area of flower bed? And then there are few options, and model has there is an answer there. And then we see there is a human reasoning uh, in step 1, 2, and 3. And then there is a decomposition followed by VMath. And that is where the answer is very close to human reasoning, and it because it is following the human chain of thought. Similarly, we have another example with of four-dimensional metric for evaluating a two-step problem using both loose and strict setting. So they have conducted a thorough evaluation of existing LMMs in visual mathematical reasoning, and they have revealed a negative correlation between solving step and problem specific performance. They have confirmed the IK issue of LMMs can be effectively improved via knowledge augmentation strategy. More notably, the primary challenge of GPT-4o like model has significantly transitioned from IK to IG, which establishes it as a first LMM advancing towards the knowledge generalization stage. In contrast, other LMMs, including open source, show a marked inclination towards rote memorization. They correctly solve composite problems, and that is why GPT-4o is much better than rest of the lot. And this is another uh, problem which we already have seen. So all in all, I think this is going to be very big very soon in terms of benchmarking, because this VMath seems to be a comprehensive benchmark for in-depth analysis of large multimodal models in visual mathematical reasoning. Also, they have decomposed composite problems into subproblems according to the required knowledge concepts and have introduced a new four-dimensional metric for fine-grained reasoning evaluation. So I think that as far as we are working towards human-like visual mathematical reasoning, this is going into the right direction. I will drop the link to this repo in video's description. Let me know what do you think, because I believe that this is one area where which is still overlooked and lot of research and fine tuning training needs to happen when it comes to mathematical reasoning. I'm very keen to know your thoughts on it. If you know of any model which you have come across that has really performed well in mathematics other than GPT-4o, let me know, because I believe GPT-4o and also a bit of Gemini and Anthropic's Claude are better than the others. So I'm more talking about the open source one. So if you have come across any open source model, including Llama 3 by the way, please let me know. I'm very keen to test them out, because still whenever I pose logical mathematical reasoning questions to these LLMs in my tests, they always struggle, especially the open source. And even the GPT-4o and these Anthropic's Claude, Gemini, even the Mistral, they are not as good as one would hope them to be. So that's it, guys. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.